Vehicle Challenge. We're here with Evan from Northwestern University out of Evanston, and we're now waiting for the official word for the judges to go ahead and flip the switch. And it has been flipped, and they're already underway. Look at that. So, Evan, tell us about the design you came up with for your retrieval.
Yeah, so for the payload arm, we used a typical robotic arm, and then we modified some of the lengths of the pieces, as well as beefing up some of the servos so that we could carry the weight of the payload. And then by combining that with Arduino code and very specific steps that it had to take to get to its final position, we were able to drip the payload, lift it to its position, place it in the rocket, and then close the door with the same robotic arm.
So far, it seems to be moving along pretty well.
Yeah, I'm very happy about this. This is one of the more stressful parts of our rocket, so we're happy that it's going smoothly so far. And there the door closes, so we're very happy about that.
Snapshot with with authority.
Yes, that was the plan. Very tight seal with some strong magnets there.
So what's next?
Well, now it's going to go through a second movement to guarantee that the door is closed. Sometimes we had issues with some of the knuckles of the gripper arm catching on the door, so we decided to go through two specific unique steps to close the door just to make sure that it was closed under any situation.
That's a good idea. So everyone's keeping a close eye on it right now. Looks like everything went fine as far as the initial arm. Now getting out of the way.
Yeah, so now it's finished, and now we're going to start lifting with the igniters. So now you see two linear actuators. These each have 1,000 pounds of force, and they're pulling down on the back side of the rocket at the launch pad to lift the end of the launch pad up to vertical. We're going to 5 degrees off of vertical, and then hopefully catching the limit switch in the right location to stop, as well as a physical gate latch that will hold it in place to guarantee it's locked in place.
The actuators, as I said, you've got twin actuators. Why did you decide to go for the redundancy there?
We did that because we wanted to make sure that they weren't running at their full load. The amount of force we required was up around 80-90% of the load that each one had. So just to be safe on the amount of load that we were putting on each one, as well as to make sure that it was very centered. If we had a single one, we'd have to make sure it was perfectly centered when we lifted, and we didn't want to get it off center and torque improperly. So
what was this one there on the back that we just saw running?
Yeah, that linear actuator is a high-speed, low-force actuator that pushes a carbon fiber rod through a U-bend so that it goes into the backside of the rocket while maintaining its position away from the blast of the rocket when the rocket goes off.
Is that what you would consider the installation of that part of the requirement?
Yes, so it pulls the igniter in with it and locks in place at the very top of the motor. So by going into its limit switch, that locks it in the final position.
Okay, everything went very smoothly. And is that it? Is it? It's in place. It's done.
We're finished. Yes, that's it. So very quick, and we're very happy with the progress we've made.
Looks like your arm there is starting to try to wave. Thanks very much and bye.
Yeah.
So tell us. Okay, we see your gate switch.